Hey everyone and welcome back. So in today's video we'll be discussing about the Consul Connect. Now Consul Connect provides service to service connection, authorization and encryption using the mutual TLS. So let's quickly understand the overall workflow, post which we'll be discussing on why exactly this is required in first place. So in today's diagram, there are two services here. This is the first service referred as a front end service, and then you have the second service referred as the back end service. So let's assume that front end service wants to communicate with the back end service. Now, as of now, the overall workflow is very simple. So front end service can go ahead and do a service discovery. It can fetch the IP address and the port number in which the backend service is listening, and then it can directly initiate the connection with that. So that is what we are aware as of now. However, the overall workflow in Connect is a little different. So now what happens here is that there are two additional proxies that are deployed. So you have one proxy here and you have a second proxy here. And if front-end service wants to communicate with the back-end service, it first initiates the connection to the proxy that is local to it. Now, this proxy that is local to it will initiate a new connection to the proxy that is local to the backend service, and from this proxy the data is traversed towards the backend service. Now one of the question that comes is why all of this additional thing is required. If a front end service can directly connect to backend service, why introduce some additional component of a proxy and make things much more complicated? So let's quickly discuss more about it. So discussing about a use case where front-end service wants to communicate with the back-end service, and there are also some additional requirements. First is that the connection should be over the TLS. That basically means that this connection between front-end service and back-end service must be encrypted. So there must be a untrusted network. So you want to encrypt the entire traffic with the help of TLS. And second is you should also have a required level of authorization. That basically means that if front-end service wants to communicate with a back-end service, according to the requirements of your application, is this a right workflow or there is something which is malicious about it? So there can be a use case where front-end will never communicate with a back-end service. So what is the authorization that you give is also a challenge here. So both of these challenges can be achieved with the help of the Consul Connect architecture. So in this type of architecture, what will happen is the front-end service will initiate the connection towards the local sidecar container. So here you see that this front-end service is communicating on port 5000 to reach this specific proxy. Now, this proxy will in turn communicate with a second proxy which is local to the backend service here. So there are two proxies, and this connection between both of this remains to be encrypted, as well as you can also have a appropriate level of authorization. So what will happen is if there is an untrusted network, since the communication remains to be encrypted, you do not really have to worry about it. Second is, as soon as this specific proxy of a front-end service communicates with a proxy of back-end service, the backend service proxy will verify if a front-end service is allowed to communicate with a backend service, and only if it is allowed to communicate will the session gets established. So that is something that can be achieved with this type of architecture. So let's do one thing. Let's quickly jump into practical. So for today's video, similar to the architecture that we were discussing, there are two services here. You have a front-end service and you have a back-end service. And the first requirement here is that the front-end service should be able to communicate with the back-end service. Now, if you look into both the front-end as well as back-end service, it states connected with proxy. So here the front-end service is connected with one proxy, the back-end service is connected with another proxy here. So if you quickly open this up and you look into the proxy info, so here within the upstream you have 127.0.001:5000. So what exactly happens is, let me maximize this PPT here. So as we were discussing, this specific proxy which is associated with the front-end service is listening on port 5000. So whenever the front end service sends the request to port 5000, in turn this specific proxy will initiate the connection with the proxy that is associated with the backend service. And this is what is referred as a upstream here. Now one more thing that you will note here is that this specific backend service is listening on port 9080. So you can also directly initiate a connection to this specific port locally. So let's try it out first. So from the CLI, first let me quickly do a curl on localhost followed by the port of 9080. And within the output here you see you get an output of backend service. Now let me also show you one more thing here. So when you do a netstat-ntlp, here you will see that there is a port 5000 that is open, and this is the port for the proxy here. So let's try it out. So our front end service is listening on port 8080. So let's go ahead and connect to the front end service first. So when you do a curl localhost followed by 8080. So even here what happens is the connection went to the front end service. So when a client sent a request on port 8080, connection went to front end service. Front end service in turn sent a request to port 5000 which is associated with this proxy. This proxy initiated the connection with another proxy that is listening, and the second proxy in turn initiated the connection with the backend service. So this is the workflow that is happening behind the scenes. Now in turn, if you decide to directly do a curl on localhost followed by port 5000, again you see it works perfectly well. That's great. Now let's also discuss about one interesting thing of the authorization that we were discussing. So if we go to the intentions tab, let's go ahead and create an intention. So within here we have to specify the source service and the destination service. So within the source service, let's say the source service is front end service and the destination service is backend service. And you can specify allow or deny. So let's specify deny and I'll click on save. Now since you have specifically denied the connection between front end and backend service, this proxy, the second proxy, will go ahead and it will not allow the connection. Let's try it out. So now first let's go ahead and do a curl on port 8080. So in the first case it was working perfectly well. Now as soon as you do that, immediately you see you get a 502 bad gateway. Similar to that, if you directly go ahead and do a curl on port 5000, again you see you are not able to get the response. Primarily because you have created this rule where front end service cannot communicate with backend service. Now this is great primarily because if there are hundreds of services within the organization, it is very difficult to manage the firewall rules. Second part is that there are limitations in terms of firewall rules that you can create in various providers including AWS. So you cannot create unlimited firewall rules. So if you have hundreds of services that are running and if you want to create complex rules like front end can not communicate with backend but front end can communicate with database and so on, it becomes much more easier to go ahead and create the rule with the help of the intention feature in console and not touch the firewall at all. So these are the two primary advantages of using the Consul Connect based architecture. Now that's the high level overview. Now in the upcoming video, we'll go ahead and implement it from scratch to understand on the steps that are involved here.